Okay, so like in this video, I want to like show off functional programming, or like what I like, what I like about the things that I like about functional programming. Um, Basically, the reason I enjoy functional programming, well, I would say enjoy. I just started learning it. So, but the things that has kept me glued to functional programming is basically the syntax and the features like pattern matching. Let me just write them down. Pattern matching. Some also have guards, but I think you can consider it pattern matching, right? Syntax, obviously, you can do more. um, Function composition. Some people also like call it like a pipeline, whichever way you like it. Those are like my main favorite features of like functional programming languages. It's just the ease of like you can like actually do more with less code basically. So let's like start with pattern matching. So pattern matching is like one of the most badass feature of functional programming, right? So like for example, I have this function. Let's say let's use JavaScript. Um, the fancy syntax, right? I have like a capitalize. I want to say to capitalize any given string, right? It should return like it should make the first character. So for example, if you pass in fish, it should return fish, right? And if you pass in only one letter, it should return the exact same thing back to you. And if you don't pass in anything or an empty string, you should basically return that, right? So in to write this in JavaScript, you probably have to like first check the length, right? You'd say, oh, is s the string dot length greater than one, right? If it's not greater than one, basically just return what it's there, right? But if it is greater than one, then now you can like do return as 0, right? Then you can some string 1. So and if we try to run this with fish, should probably get what we want, right? And if we pass only f, we should get just f, and if we pass nothing, we should get nothing, right? So now look, probably there can be like shorter ways to write this. You can like use the ternary operator and make this shorter, but it's still going to be like shitload of mess. you still have to write. You still have to write all these conditions. So like I will show you the exact same thing right now in two functional programming languages, Haskell and in Ocaml. So let me just tag this as so in Haskell, um, let me just create this part. I can create the same capitalized function that is meant to take in a string and return a string, right? And the power of pattern matching right now, you are going to see. So you can basically define this function like multiple times. So I'll create the first definition for when the string is an for when like when the string is an empty string, you can just say if it's an empty string. So in Haskell, a string is like an array of characters, right? And you can just say it should return same thing, right? And you can like now Now the power of pattern matching is here. So I can say when the array, when the list has only one item, I can just return only the item, right? And I can say now if the list has multiple items, I can now say, okay, you can capitalize this part and append it to the rest, right? Uh, yeah, I've forgotten how I do uppercase. Yeah. So Haskell has this to upper or whatever this that is. Yup. Okay. So you can just say it's upper x and append it to excess. And if I do print print um capitalize fish, I should get yeah, it's oh what, let me just go to the learn Haskell and why. It's been a while I wrote Haskell code. Yup, something like this. Probably I need to put in a bracket, I think. You know what, let me just put in a bracket. Probably it's a bracket that's my problem. No. Yeah, so it's a bracket. I need to import to upper. I need to import it from module char. So I can basically say that it's, yeah, say import char. Okay, data.char. Mm. So import qualified. See. Yeah, so I'm meant to return a string here, so sorry about that. Okay, finally, yeah, so you can see if I wrote the same amount of code, but like it feels the syntax, the syntactic sugar is like it's very cool, right? You're basically like matching patterns basically of what the input is going to look like. And I probably don't need to write it with this much code. So because I can just do, you can also do wildcards, right? So once I have this pattern that I need, I can delete all these guys up here. And I can just say for every other thing that doesn't match this pattern, just return it, right? Return the same thing back. So, and it is still going to work the way I want. So this is going to be fish. This is going to return the small letter f. Ah, um, yeah, probably. So it's this still matches for an empty array. Let me like return this guy. So yeah, probably still need to leave this guy, but I can like delete this guy and leave the case and do this. So yeah, f should be like a small f, and an empty string should be an empty string, right? So yeah, so this is basically what I was saying, like what you can do with pattern matching. So in Ocaml, you can like basically do the same thing. You can say, let's capitalize. Just going to take in a string, right? And it's meant to return a string, right? So, but the only difference with Haskell, with Ocaml is strings are not lists of strings. So like strings are not like a list of characters. So I'd rather like do this, like to make this explanation easy, I would rather just make this a list of characters, right? So I can say char list and should return char list back. So you can do the same pattern matching in Ocaml, but without like it's more code, but like I don't know why I can't do multi-line. I can't go to a new line for some reason. Ah, okay. Yeah. So you basically say match S with, then you start writing your patterns, right? Don't know if this is like a Vim mode or something that, but this is like very annoying. And like none of the Vim shit keybinds are working. Okay. Okay, so you can basically do your pattern here and you say, wait, what? Ah, so tab doesn't work properly in this editor. So now I can say match when basically do the same thing when there is a an item in the array and nothing, right? And you just return the item. And you can also like say when there is an item and there is other items, then you can like uppercase it, right? You can uppercase it, right? Then you can like append it back to the rest of the array. You can also like then you can like put the final white card that you don't care about. Like if any other matching comes here, just return the same input back, right? And here we need to return it as an array. So now we can also do the same thing here and like print out what this list is going to look like, right? So basically capitalize, and we try to like print going to do some fancy Ocaml stuff right now. Yeah, so it says F, right? But if I put in like fish, sorry, ish. Oh yeah, and in Ocaml, like the arrays are this way, right? So now it's capitalized, and if I put in an empty array, it's just it turns nothing. Bam. Okay. So and like it looks more pleasing to me. I don't know. Like it looks more pleasing to me. So that's basically what pattern matching is like, and I basically I like not having to write all these braces and all. That's why sometimes I enjoy writing Python instead of like all this C style of languages. So yeah, but like that's basically pattern matching, one of my favorite features of functional programming. I'll talk about guards in the next video. So I guess I've touched on pattern matching. And probably syntax. You've seen like how it looks. It looks way cooler, right? And like you're basically doing more with less. I'll talk about guards and pipeline, or let me just talk about it now. So basically, this is what a pipeline is in Ocaml. So basically, you pass the output of a function, and the output of this function, you pass it as the first argument to this function, and you pass the results from this function to the argument of this function, and the result is going to be the argument of this function, just like pipes in like the bash terminal, right? That's basically what pipeline is. And it's like an Ocaml feature. In Haskell, we call it function composition. So let me show you in Haskell. If I wanted to do the same thing, if I wanted to like pass in, I wanted to like create a pipeline that is going to take a list of now that's going to take in this string and then capitalize it and then print it. So I'll basically just create do like this. So the thing is, you know how in Ocaml the function comes first and like the input, like it goes sequentially from like the beginning of the pipeline to the end of the pipeline. In Haskell is a bit different. So you have to go backwards. So now capitalize is the first is the first thing we want the pipeline to do, and the last thing we want the pipeline to do is to print, right? So this is how you do it in Haskell, and you can pass in the arguments you want to pass. So yeah, so you basically created a pipeline, it goes backwards. So like that's like it might be confusing at first, but you get used to it. It's basically a pipeline. So that's basically what pipelines are. And function in Haskell they call it function composition. In Ocaml they call it pipelines. But regardless, I like it. And guards is basically like a fancy pattern matching. Like Python also has this. So it's basically a way for you to like do like if else in your pattern matching, something like that. In Ocaml, so when you have this pattern matching, you can like do like a when. Maybe you can say when x is less than one, something like that. So that's basically what a guard is. So a guard is a way to only match a pattern if a condition is met. Basically, that's what it means. So yes, those are my favorite features of of functional programming and why I've been like enjoying it. It's not something I use on my day job. I just do it for fun, and it's because it's cool. I wish I could do more of it in my day job because that would mean I would have more time to learn more of it, right? But my day job, I think that there is like the adoption of functional programming is not yet a thing. So, all right, cheers, bye.